Hi everybody, in this video let's learn about joint variations. In the previous video I talked about the direct variation, right? For example, if I tell you y varies directly as x, we write this way. This is variation relations. If I want you to write in equation form, it will become y equal to kx. You will notice that we only involve two variables, y and x, and the k is the constant of variation. In joint variation, it will involve more than two variables. If I tell you y varies directly as x and z, then it will be like this. Y varies directly as x and z. If I want you to write this in equation form, same thing. We just add a constant of variation in front of this x, z. Y equal to kx. The way how we solve the question for joint variation is the same thing as solving the question for direct variation. Okay, now we have few examples over here. Let's go through one by one. Let's look at example number 9. We want to write the relations using decimal and in equation form. Okay, let's look at A. Okay, this is what I showed you just now. Y varies directly as x and z. Y varies directly as x and z. So if I want you to write this in equation form, we write the equal symbol, add a k, constant of variations, then x, z. Okay, how about B? Y varies jointly. So this is the same thing as varies directly. Y varies jointly as x and z is actually the same thing as y varies directly as x and z. So we write exactly the same answer for B. Okay, if you see varies jointly, it actually means varies directly. Okay, how about C? Y varies jointly. Now you know the meaning, right? Okay. As x and the cubes of z. So be careful, we have to add the power 3 over here. So when we want to write in equation form, y equal to k x z raised to the power of 3. Okay, now let's go to the last one, D. Y varies directly as x and the square of z. The square of z. So the equation form will be y equal to kxz square. Okay, let's try this example number 10. Given y varies, let me write again the symbol. Y varies directly as x and the square of z will be like this. So if I want you to write in equation form, normally when we want to calculate, right, first thing we change this to equation form. Okay, so we want to find the equation relating x, y, and z. Now we have 3 variables over here. So what we need to do is find the value of k first. When x is equal to z equal to 1, y is equal to 6. Okay, I'm going to put all this value into this equation. Y is equal to 6. K, I don't know. I want to find the value of k. X is equal to 2. Z is equal to 1. And we have a square over here. But 1 square still the same, still equal to 1. Okay, so 6 is equal to 2k. 1 square is equal to 1. 2 times 1 we will get 2. So 2k. So k will be equal to 6 over 2. K is equal to 3. Now we have the value of k, the constant of variations. What we need to do is plug in this value into this equation. y equal to k, which is equal to 3, x z squared. Okay, so this is the answer for these questions. Let's look at the last example that I'm going to show you in this video. So this question, we have to be more careful. The mass of copper m kilogram, so this is a kilogram, deposited by electrolysis in a given voltmeter varies directly. Okay, so this m varies directly as the current I and the time t. Okay, but we have to look carefully the given unit here. This is kilogram, this is ampere A, and this is second. Okay, now let's proceed to read the questions. 4.8 times 10 raised to the power of negative 4 kilogram of copper is deposited after 30 minutes. Okay, you have to be careful here. The given time here is not in second but minutes. Okay, when the current is 0.8 ampere. Calculate the mass of copper deposited after 1 hour when the current is 0.5 ampere. Give your answer in gram. Okay, so first I write it in equation form. M equal to KIT. So the M is kilogram, is in units of kilogram. This is ampere, this is second. Okay, so now I'm going to use this all given information over here. This one, this, and this. Plug in into this equation and help me to get the value of K. But what you have to be more careful is kilogram, no problem. Ampere, no problem. But this is minute, this is second. What we need to do is change the minutes to second first. It's equal to 30 times 60 second. Okay. Now when the t is equal to 1800 second, the current is equal to 0.80 ampere, and the mass, the m, is equal to 4.8 times 10 raised to the power negative 4 kilogram. Okay, so now I can use this all value here to help me to get the value of K. M is equal to this, 4.8 times 10 power negative 4 is equal to K. Okay, I don't know the value of K. I want to find the value of K. I is 0.80. The T is 1800. Okay, 1800. Okay, so this 4.8 times 10 raised to the power negative 4 is equal to, okay, so that's part which is press of a calculator. 0.8 times 1800. So this is 1440. Okay, we have a K over here. So K is equal to 4.8 times 10 power negative 4 over 1440. Okay, find the value of K. Okay, let me key in into the calculator first. 4.8 times 10 to the power of negative 4, okay, divided by 1440. Okay, so this answer, we have 6 0 over here, right? Okay, 1 2 3 4 5 6. Okay, so this is the value of K. Okay, let me double check again. Okay, correct. So now I'm going to plug in this value into this equation. So now I know that M is, okay, how about I use another color? M is equal to 1 over 3,000,000 IT. Okay, so the question asks us to find the mass of copper deposited after 1 hour. Okay, this is 1 hour, and we have to change to second, right? Okay, when t is equal to 1 hours. 1 hours, if you want it to change to second, you have to times 2 times of 60, right? So it's equal to 3600 second. Okay, let me show you over here. 1 hours is equal to 1 times 60. When you times 60, it becomes minutes. If you want to convert further to second, you have to times another 60, which is equal to 3600 second. Okay, the t is equal to 3600 second. Not enough space, let me, okay. And the current is equal to 0.50 ampere. So now I want to find what is the value of M. M is equal to 1 over 3000 times 0.50 times 3600. Okay, so just take our calculator, key in all this value. Answer time 0.5 times 3600. Okay, so this answer, if I want to change to decimal, it will become like this: 6 times 10 to the power of -4. But this is kilogram, okay? Kilogram, not gram. Since the question asks us to give our answer in gram, so what we need to do is we have to convert this to to gram. How to convert to gram? We just times 1000, right? Okay, so the answer is 0.6 gram. So when you see the unit, you have to be careful. Sometimes you need to convert the unit yourself. Okay, so that's all for this video. Hopefully you understand better after watching this video. Thanks for watching. See you next time. Bye bye.